I always thought that coding is the most important skill for software engineer and everything else is secondary. But when I was asked to write a high-level design document for a massive feature, I wrote crap that nobody could understand and embarrassed myself, even though I was a pretty good programmer. Turns out that the higher you go, the higher writing English is getting on that skill tier list. And starting at senior level, it really becomes more important than coding. Writing great design documents in particular is what gets a great engineer to staff and tech lead roles. So today I'll give you everything you need to write perfect high-level designs. Exact thinking process of coming up with a design that brings clarity, specific format of how to present it, and a non-vibe coding way to use AI that amplifies your judgment instead of ruining it. But here's something completely new that's happening in tech. AI writes code now, right? So that transition from code to prose didn't stay at senior level. It moved down to everyone. Now every noob is writing English, and the problem is it's actually a more demanding skill that builds on top of coding foundation. If you are a junior or mid-level engineer, you were supposed to learn to code first and then move to higher level of abstraction. But now if you use AI for coding, you kind of already act like a tech lead. And if you can't write a clear design document, you're the first person that becomes useless. So now you need to understand what is a good high-level design. A couple of months ago, I gave a middle engineer in our team a task to implement a big feature of integrating LLM analysis into an existing system. When he got the task, he was a little stunned and wasn't sure about how to approach it. It wasn't surface level, and I knew it would require a lot of new code. So I asked him to write a high-level design document before implementing it and send it for me to review. It also was a time-sensitive feature that we needed to release pretty soon, so I thought that a clear plan would speed up the whole process. I got the HLD for review. It was a 5-page document with tons of boilerplate AI-generated slop that had absolutely no meaning. But also, the design for feature itself was still unclear in some critical points. There was no clear steps for implementation, so what to do next question still had no answer. Writing that thing took him 3 days. That was a remarkable waste of time for the entire team. A bad HLD wastes everyone's time. It creates more questions than it answers, and you'd be better off writing nothing. A good HLD does one thing: it removes uncertainty. After reading it, the next steps are obvious for you, for your team, and for AI coding tools, which is, by the way, the massive life hack. Removing uncertainty inside an engineering team is the S-tier outcome from engineer that any company could get. If you're doing this, your road to staff and tech lead roles is becoming very straightforward. So when I write an HLD, I focus on these 5 things. First, business awareness. The design is shaped by what the product actually needs, not what's architecturally elegant. Second, context. It reflects the current state of the codebase and builds on top of that without breaking stable patterns with no good reason for that. Third, future thinking. It predicts load, traffic growth, future requests, failures, and faults before they happen based on spec and requirements. So fourth is past thinking. It goes deep into what exists now, catches decisions that no longer fit, and proposes the right moment to change them if it's needed now. And fifth, no overcomplication. Every added component is justified by the requirement. Complexity for its own sake is a red flag. The middle engineer's HLD lacked context and past thinking. It was reinventing the functionality that already existed in other places and could be reused, and didn't explain the reasons for not doing so. By the way, it's the smelliest footprint that AI leaves in your designs when you offload thinking to it. It also had weak future thinking because it didn't cover any failure modes, which is very important in a LLM integration into a real-time API. That's why it failed to give clarity. You would ask, then why do you even write high-level design if it only hurts? So here's another story that proves that your ability to create HLD following these principles makes you irreplaceable. So I'm working with the Xfang team lead, and one of the main services in our product is an ad server. Whoever worked in marketing tech knows how complicated they can be. So we had to implement a massive feature into our product that required not only new functionality, but also rewiring almost all business logic in the ad server and all the consumers. The requirements for ad server are very strict, and it doesn't allow for bugs and performance issues. Jumping straight to coding for this task is not even an option. It's a core of our system, very sensitive to changes and especially bugs. But also it's just big. You cannot simply implement a feature there before carefully planning it. So our team lead did his magic and created an HLD that brought full clarity to the entire team about how it should work, what should be re-implemented and what shouldn't. Working on it became simple, and the result is a reliable, maintainable system. Even though I was coding this feature up, I know that almost all credit goes to team lead for designing this well. He will never be replaced. To be capable of such magic, you need to have very strong technical foundation. That's why I created the Irreplaceable Engineer Lab. Every 6 weeks, you go deep into one foundational topic for backend engineers. You start with an assessment that exposes your actual gaps, not what you think you know, but what you can explain and apply when designing a system. Then you go through a structured book-based curriculum where you get reading maps for a book chapters and weekly challenges, system design critiques, architectural trade-offs, code reviews that build your judgment and the kind of thinking that makes your HLDs useful. For now, lab is limited to 50 engineers, link in the description. Okay, let's go back to the topic. But why can't you just go and vibe design the whole document in 15 minutes with AI? If right now you go and ask Claude Code to generate a high-level design for a feature, it will spit out perfectly looking document. I've seen engineers submit AI-generated designs in review, and it is immediately obvious to anyone. And I can tell you, it's not a good look to waste people's time. There are 3 things AI fundamentally cannot replicate. First, deep code-based knowledge. What is currently live, what's working, what's broken, what the real limitations are. Understanding of what can be changed. Not just what exists, but what the architecture allows and what it prevents. Third, and the most important, is business and context awareness. The same feature can be designed in 5 different ways depending on a business model, team size, and current priorities. AI does not know any of that. You can feed the entire code base to AI, but what we found is that it will constantly make wrong decisions. And a big HLD might involve hundreds of mini decisions that compound into a good or bad design. And now we will go through the entire step-by-step process of coming up with a great design for a backend system. I break this into 6 phases. So most engineers do this one mistake that kills their ability to make correct decisions. They spend 90% of the time on a solution and only 10% on understanding the problem. You need to invert this. Most of the work is done by understanding the problem and context. Without that, you're doing the same thing AI does. So here's what you should do. First, you need to know what exactly you are solving, and the more specific you can get on the actual problem, the better. For example, improving performance is not a good definition for a problem. Something like improving performance of payment service to decrease checkout latency is better. Also, who is it for? End users, internal teams, infrastructure team, but also very important to be specific on non-goals. Usually there are a lot of things that could realistically be in scope, but deliberately aren't. Name them explicitly. For example, if I implement a new service, refactoring other services to use the new one can be either in scope or outside the scope of this particular design. Both options are possible, but it should be decided now. After that, you need to define what success looks like in numbers. So in our performance optimization example, it could be something like P95 latency under 200 milliseconds. It's also a great idea to mention what happens if we do nothing. It may sound redundant, but a lot of unnecessary complexity can be avoided on this level. This gives you all information you need about the problem and constraints around it to make correct decisions. So let's move to the next step. Breaking don't repeat yourself principle is AI's favorite thing to do. It's also one of the worst things you can do to a code base and your team. Proposing to implement something from scratch that already exists in other service and could be reused is what gets HLDs insta-rejected and you losing your reputation. So start by observing what already exists and works good. Write down the actual limitations of the live solution. What is actually happening in production? And check all the constraints like what other teams depend on. Your change might silently break them if you don't know what they're using. Remember the HLD I reviewed, that is what skipping phase 2 costs you. After observing the system context, you're ready to move to the next step. Turn requirements into numbers. Making good design decisions is hard, but it doesn't require you to be a genius. You just need accurate information about requirements. When you have that, most decisions become obvious. Vague requirements lead to wrong decisions, so you need to translate words into numbers. Many users means nothing, but 10 million daily active users means 5k requests per second at peak. Now you can design for that. Fast also means nothing, but P95 latency under 200 milliseconds is something you can actually measure and build for. Reliable means nothing, but 3 nines uptime means maximum 8 hours of downtime per year. That tells you how much redundancy you need. Scalable also means nothing. Handle 3 times current load within 6 months is a real constraint you can plan around. Designing for 100 or designing for 1,000 users and 1,000,000 users are completely different architectures, and over-engineering a zero-user startup is as bad as under-engineering a scale-up. I was once working on a Swedish startup as a middle Python engineer, and the tech lead there was, by the way, very competent and smart. He used to work in Ericsson and other telecommunications companies. Anyway, but we made a mistake of designing a system that had 0 users with event-driven architecture, microservices, Kafka, and all of the stuff you can imagine. I spent most of my time wrapping my middle-level head around event-driven inter-service communications and accomplished mostly nothing in the 6 months I was there. The startup, by the way, failed. Not sure if it was because of over-engineering, but it definitely didn't help. So define your requirements as specific and objective as possible. Most of bad HLDs and other design documents that I've written or reviewed were multiplying complexity instead of decreasing it. And that is why, to be honest, no one really likes writing or reading HLDs. They are perceived as a waste of time, and the bad ones actually are. So start with the fewest possible moving parts. Ask yourself, can one service handle this? Don't split into microservices before you have 30 plus developers. Most teams don't need them. Can the existing database handle this? Don't add a new one unless there's a very specific reason to do so. And it's cool, or best microservices patterns disallow to use one database is not a good reason for that. Every component you add is a new way for system to break. Justify each one with a real requirement. Then trace the data flow end to end through your components in your design. Follow a request from the moment it enters to the moment it leaves. This step catches more design flaws than any system diagram. Every HLD has 2 to 3 defining decisions. You have to emphasize them. For each one, list the potential options. Always include do nothing as an option. Compare the trade-offs between them and explain why you chose what you chose. And name the downsides of your choice. This helps you to be objective about your thinking. Every option has a downside, even if it's the one that seems perfect to you. I've read that Google's tech lead says that alternative considered section is one of the most important. It shows why your solution fits this specific context, not that it's universally correct. And by the way, that is a main sign that the person designing actually knows what he's doing, because you're not emotionally attached to decisions you made. Design for failure. This step is the most dangerous to skip. It's better to not ship anything than to ship always broken code. The simplest way to design for failure is to ask yourself and write down on a piece of paper, how would I guarantee this system fails? Then write every answer down. Make sure your design addresses each one. For example, what happens when the database goes down, when the traffic spikes 10x, when a third-party API stops responding, like the LLM API, for example. This is called pre-mortem technique. You imagine the system has already failed, and then you work backwards to figure out why. It will help to identify risks that optimistic planning always misses. Putting all this into writing is the simplest part of designing a system. But as I said in the introduction, there's a great use for AI in this process. You cannot offload the thinking process and decision making, but you absolutely can use it to avoid typing all of this information in a clear way, creating architectural diagrams and researching trade-offs for options. So I've compiled a comment for Cloud Code, Cursor, OpenCode that I and our team is using to help engineer with the HLD writing process without interfering with their thinking process. It and my entire AI engineering workflow is free to get in the description. You can install them into your setup, just use one command and you're all set. And here is the simple template you can follow for each HLD you write. By the way, the comment will handle this entire structure for you and you only need to worry about the design itself. First, you write the context, one short paragraph about the world we live in. Here is what exists today. Here is the problem. It should be just enough for someone unfamiliar to get up to speed. Then goals and non-goals for this specific design. 2 bullet lists, what the system will do and what it won't do. The non-goals are the secret weapon because they force you to make scope decisions before you fall in love with the design and then end up sending 100,000 lines of code PR to a team lead and getting screamed at. Next is design overview, a short summary of your chosen solution. Think of it as a TLDR of your architecture. 1 paragraph before you go deep into it. Detailed design is where the meat is. Components, how they connect, how data moves through the system from start to finish, also technology choices and the trade-offs you made. This is where your diagrams live too. It is also a great idea to include use case diagrams for the main user flows. So who uses this and what happens when they do? This provides more context to the engineer who hasn't designed this system. Alternatives considered section is where you list every serious option you looked at and why you didn't pick it. Include do nothing as an option too. Cross-cutting concerns section covers security, privacy, observability. Keep it short, just show that you thought about each of this. And finally, implementation phases. This one is entirely optional. You only need it if the rollout is complicated, like a phase migration or a gradual traffic shifting. You can skip it, but in our case, the HLD that team lead wrote had very specific phases of implementation and it brought very specific benefits. First, it allowed to start using and testing portions of the feature without releasing it in full, which is very nice. It also allowed to split work by engineer and also keep PRs from becoming massive, which helped with review process. So this is how you write great high-level design that makes you extremely valuable to the team. But knowing how to create value in a team is only half the problem. The other half is not wasting your energy on things that don't matter. If you are ambitious but lazy backend engineer, watch this next. Goodbye.